Probably forgot, and that's okay. So, do you guys remember back from chapter 2, we talked about what happens when you add or subtract a constant to a data set. I'm going to flip back to it in my extremely organized notebook. Oh, here it is. Okay. So adding and subtracting a constant or multiplying, dividing a constant does not affect the shape of the distribution. Okay, so we're going to write that first. So you guys remember when we added or subtracted a number or multiplied or divided a number, it didn't change the shape at all. Do you want me to show you my thing we did? Okay. 1 second. I'm going to be efficient and show you last year's notebook.
That was like when it was rotated.
When it shifted down the x-axis.
Yeah, when it like spread out.
Yes, yes. Okay, okay, here it is. Here it is. Okay. So this was our original data set. And in this one, we added 3. And the whole thing was we just shifted it up 3 units. The shape did not change and the spread did not change. It didn't get any more spread out. However, when we multiplied by 2, the shape stayed the same. It was still uniform, but the spread got 2 times farther apart. Okay, and then we did a summary of that, which we're going to summarize here again. Quickly, hopefully, if I can figure out what I want to say in a short period of time. Okay. Okay, adding and subtracting a constant does not change the shape. It also does not change the measures of spread. Let's brainstorm some measures of spread. What do I mean when I say measures of spread? Not butter or peanut butter. IQR, excellent. Range, I heard. There's another one. It's got a long name that I'm too lazy to write. Standard deviation. Variance. There's probably others. Those are our most common ones. Okay. This is the part that you need to know. It does, however, add or subtract that number from the measure of location. So what I mean by that is that's the shift up the axis. So if we add 3, everybody gets added 3. What are measures of location? Give me some examples of those. Quartiles. You're overthinking it. Median. Mean. Max. Min. Percentiles.
Standard deviation also.
Standard deviation is a measure of spread.
So it's like 1 standard deviation.
But it's how spread out.
Okay.
You're even doing it with your hand, which is amazing, and I love that. Okay, percentiles, z-scores, all of those things, measures of location. Okay, so that was when we added or subtracted a constant. You got to just think of it as a shift up or down, not spread out anymore, just a shift. Okay, now we're going to multiply or divide a constant, which is going to make it more spread out. So, however, it does not change the shape still. And we don't need to list those all out again because we listed them out up here. Okay, we have two examples to do. Any questions about this so far? Anyone want to see my dot plots again? We're good? Okay. Anyone still writing? Please let me know if you're still writing. You sure? Okay. All right, so we're going to do the first example. I'm going to give you several minutes to get this situated. And then after you get this out, after you get this written down, get out your graphing calculator. This is literally going to take you longer to write down than it is for us to do the problem, but that's okay. I probably got this problem because my husband works at a car dealership. Okay, if you guys could do me a favor and put your pencils down aggressively when you're done so that I can tell. That's perfect. That wasn't aggressive enough. Luckily, I'm right here so I can see. Perfect. He did. It's kind of satisfying too. What, we're all tired. I'm trying to keep it going. I'm trying to keep it light. Okay, I want to go slow here. Make sure first, just go real slow. Okay, I told you guys my husband works for a car dealership. He's not in sales. I probably made this problem up if he worked there. I don't know. But it's just my guess. I made this up last year, so we'll see. Okay. Let X equals the number of cars sold during the first hour of a randomly selected day. Okay, so let's make sure we understand what the table is saying. There is a 30% chance of selling 0 cars in the first hour. There's a 40% chance of selling 1 car in the first hour. First hour being like, let's say 8 a.m. to 9 a.m. if they open at 8, does that make sense? There's a 20% chance of selling 2 cars in the first hour, and there's a 10% chance of selling 3 cars in the first hour. Does that make sense? So I guess customers are not really beating down the door of the car dealership to buy cars, but that's fine. Okay, everybody good? Okay, now, first, is it a valid probability model? Does it list all possible outcomes, assuming that they sell only up to 3? And are all of the probabilities between 0 and 1 and add to 1?
Yes.
Okay, perfect. Okay, this is a little bit of review. So now we're going to find the mean and standard deviation of X. And we're going to practice that. So stat, enter, clear them out. 0, 1, 2, 3. I know this is practice from earlier this week, but it's never bad to do, right? Muscle memory, muscle memory. Okay, so outcomes in L1, probabilities in L2, then go stat, calc, one variable stats, and make sure that you have your list is L1 and your frequency list is L2. Does anybody need help with that? You sure? Okay, and hit calculate, and you should get a mean of 1.1 cars and a standard deviation of 0.943 cars. Okay, any questions about that process? Okay, now what we're going to do a little bit more review. We're going to interpret both of these things in sentences, but we're not going to write them down. We're just going to do it verbally. Okay, and I'm going to flip back for you. Okay, so this is either called the expected value or weighted average. If you want to, you can put that in front just to remind yourself that that's expected value or weighted average. That's the same thing. And the sentence for that is over many, many whatevers, we would expect about whatever on average. Okay, so ours would say over many, many randomly selected days, we would expect to sell about 1.1 cars in the first hour on average. Does that make sense? Okay. And then we would say over many, many randomly selected days, the number of cars that we sell in the first hour would typically vary from the mean of 1.1 by 0.943 cars. Just remember that whole typically vary by from the mean thing every time you do standard deviation. Okay. Next, suppose each car sold earns a $500 bonus for the dealership. Let Y equals the bonus received from car sales during the first hour of a randomly selected day. Okay, so here's my question. If this up here is X, what is the equation for Y? What is the operation happening in this problem? They get $500 for each car. What operation is that? $500 each. I just wanted multiplication. I was looking for multiplication there. $500 for each car. So that would be 500 times each car. Okay, so think of it like this. This will help. Y equals 500x. I'm just saying for each car they sell, they get $500 for a bonus. Okay, so now that we've narrowed down that it's multiplication, let's scroll up. We are going to make a graph. We're going to expect that the shape won't change at all. It will multiply the measure of spread, and it will multiply the measure of location. The mean is a measure of location. So you're going to say the mean of Y is 500 times the mean of X. I just took the mean of X and plugged it in. Are you guys okay? And then for units, I'm going to put a $sign on there. Okay, so the question is, do I multiply the mean? Yes. Do I multiply the standard deviation? Yes. I'm getting really close to the coil over there, and it seems to be okay. All right, now we're going to look at the graphs to make sure that the shape did not change. So 0, 1, 2, 3. Okay. So what should I do here? How high should this bar be? 0.3. And this bar? 0.4. 0.2. 0.1. Okay. And I just promised you a minute ago that the multiplication by a constant will not change the shape. So that means that these should all be exactly the same. And I don't even have to worry about it because multiplying by a constant does not change the shape. Okay, however, Mrs. Talbot, excuse me, I have a question. Oh, yes, Mrs. Talbot, what's your question? Well, you were just saying a minute ago that it makes it more spread out, but it doesn't look more spread out to me. It looks exactly the same. You just went over one graph paper squared. Oh, well, Mrs. Talbot, look at the scale on the bottom of your x-axis there. It is more spread out. It's just that I called this 0 and 1, and I called that 0 and 500. Oh, wow, thanks for pointing that out. Mrs. Talbot, I would have been confused all weekend. I wouldn't have been able to sleep. I'd have been waking up in the middle of the night stressed about how it didn't get more spread out. Yeah, well, I felt like I kind of cheated because it should be like, if I call this 1,
Yeah, I can get that.
yeah, we're good. Okay. Anyone else writing anything here? You all done writing? Your pencils indicate so. Okay, this is the last bit.
This is the last bit.
Last bit, yeah. Last bit of the day. It's not too bad. It's just review. Oh, I have a joke for you also. Now that I think of the joke, it's kind of insulting, but it's fine. Stats can be insulting. Like once you figure out, your percentile in any way, shape, or form. Like say,
Oh, yeah. Okay.
yeah.
And then you realize it's 2 pieces of data.
Yeah. But you can't take it personally. Donuts. I feel like I got a little tiny, like 1% econ going on here. Because I'm spending money on coffee and donuts in order to lure more customers in. Mhm. If nobody buys anything, then it'll be sunk costs. I'm just learning by osmosis being next to her classroom. Because some of the videos are so loud I can hear them. Yeah. Oh yeah. All the time. There's that one type of video she plays a lot, and it's got that same music that plays over and over. I don't know, but I don't know what they are. But I noticed that music. I'm like, oh, they're listening to a video again.
The other day where we had to test our safer cars.
How do you do that?
I don't know.
Oh,
I don't even know what the like purpose of that.
how do I do it? Can I Google it? Oh,
It was
just
like-
because
it
she
was-
cares,
It was
like,
like 30 minutes for like.
Yeah, like 30 minutes
no-
of searching up which car was yours. But she walked around and asked.
And she said I was gonna die because my car, like if I
Yeah,
make
she
something
told you
head
they were
on,
gonna die.
I was gonna get thrown out of my car.
all right, moving on. Okay. All right, last bit, then we're done. If the manager spends $75 on coffee and donuts for the customers each morning, then my husband would complain that, oh wait, did I just put an if and a sentence? Ah. There we go. Okay. Fixed it. Now it's, oh no, it's like a compound. Anyway, it's fine. Okay. If the manager spends $75 on coffee and donuts for the customers each morning, as I said, my husband would complain that it would not be for the employees, it would be for the customers because he would watch them eat the donuts and he would be sad, but it's fine. Let T equal the total profit in bonuses after buying coffee and donuts. Okay, so here's my question. What is the equation for T? T equals, so it's profit after buying coffee and donuts. So profit and bonuses. The correct answer is Y minus 75. Bonuses minus $75. Nice. Okay. Okay. What operation is this? Subtraction. Okay. Should the shape be affected by subtraction? No. Okay. So shape not affected so right skewed. Where am I getting that right skewed from? Yeah. The little graphs we did, yeah. Okay, not affected by subtraction, so right skewed. Okay, mean of Coach T. Okay, he was so cute. Okay, so here's the formula, but my question is, are measures of location affected by subtraction? Yes. Okay, so the mean was 550 minus 75. 475. This would be really helpful if it didn't go on to a second page, I think, because you could look above it. You did that. You fit it all, didn't you? Yeah. Okay. Oh, yeah, that's perfect. It's way better because you can look right above and see what happened. Anyway, okay. Last thing. Is spread affected by subtraction? No. It's just y. Standard deviation of y. Don't subtract the 75. It doesn't get less 75 more spread out. You just leave it. You just gotta drop your pencil and walk away. Let's just write a note. Although now I've screwed up the note. This is so sad. This is so sad. Oh, it's gonna be awful. Oh, it's okay. Oh my gosh. Friday afternoon, I just get so tired. Okay, that's it for that. You ready for your joke? We did that again. It was chapter 2 again. Here's your joke. It says, congratulations, you've reached mediocrity. Because you're in the middle of the bell curve. Look at the large group that's in the bell curve middle, the blue. That's most everything.
I think I'm 2 standard deviations to the left. Yeah.
So you're down here in the red, you say?
Yeah.
You're on the M status?
I might be in the, what is it, 0.0? Yeah.
No.
I'm on that 0.05. Between the Y and then the start.
Oh, the little bit that we don't draw. I don't think that's actually true. The problem with that is that you have to think about all of the children that can't pass Math 1. So, yeah.
Hey, I almost didn't do that. It was over COVID though.
Oh, well, that doesn't count.
I don't even know if we took tests over.